Today we are going to learn about structure of an atom. Let's first observe the atom in a microscope. It was known by 1900 that the atom was an indivisible particle but contained at least one subatomic particle. J. Thomson identified the electron. The mass of an electron is considered negligible and its charge is -1. An electron is represented as E-. Even before the electron was identified, Ugly Goldstein in 1886 discovered the presence of new radiations in a gas discharge and called them canal rays. These rays were positively charged radiations which led to the discovery of another subatomic particle equal in magnitude but opposite in sign to that of the electron. It was the proton. Its mass was approximately 2000 times of that of the electron. Proton is represented as P+. The mass of a proton is taken as 1 unit and its charge is +1. The neutron was discovered by James Chadwick in 1932. It had no charge and a mass nearly equal to that of a proton. It is not present in hydrogen atom. It's represented as N. Structure of an atom. In Dalton's atomic theory, he suggested that the atom was indivisible and indestructible. But the discovery of two fundamental particles, electrons and protons, inside the atom led to the failure of this aspect of his theory. It was then considered necessary to know how electrons and protons are arranged within an atom. For explaining this, many scientists proposed various atomic models. Thomson was the first one to propose a model for the structure of an atom. In this video, we will learn about three models: Thomson's model, Rutherford's model, and Niels Bohr's model. Thomson's model of an atom. In Thomson's model of an atom, the electrons are in a positively charged sphere. It is like dry fruits in a spherical Christmas pudding. So it is also called the Christmas pudding model. Thomson proposed that an atom consists of charged sphere and the electrons are embedded in it. The negative and positive charges are equal in magnitude, so the atom is electrically neutral. Although Thomson's model explained that atoms are electrically neutral, the results of experiments carried out by other scientists could not be explained by this model. Rutherford's model of an atom. In Rutherford's experiment, he took a source of alpha particles, lead plate and photographic plate. Then he took a gold foil of 1000 atoms thick. Alpha particles are doubly charged helium ions and have a mass 4u, so they have a considerable amount of energy. It was expected that the alpha particles would be deflected by the subatomic particles in the gold atoms. Since the alpha particles were heavier than the protons, he did not expect to see large deflections, but it gave totally unexpected results. When the alpha particles hit the gold foil, the results were that most of the fast moving alpha particles passed straight through the gold foil. Some of the alpha particles were deflected by the foil by small angles. 1 out of every 1200 particles appeared to rebound. This is the model when it strikes the gold atoms. Rutherford proposed that there is a positively charged center in an atom called the nucleus. The electrons revolve around the nucleus in circular orbits. The size of the nucleus is very small as compared to that of the size of the atom. But the drawbacks are that the revolution of the electron in a circular orbit is not expected to be stable. Any particle in a circular orbit would undergo acceleration. During acceleration, charged particles would radiate energy. Thus, it loses energy and it will fall into the nucleus. Then, the atom will be highly unstable and matter would have not exist. Niels Bohr model of an atom. Niels Bohr's model of an atom was that it had a nucleus and it had 4 discrete orbits: k orbit, L orbit, m orbit and n orbit. Postulates of Niels Bohr model of an atom are: only certain special orbits known as discrete orbits of electrons are allowed inside the atom. While revolving in discrete orbits, the electrons do not radiate energy. Distribution of electrons in different orbits. The following rules for writing the number of electrons in different energy levels was suggested by Bohr and Bury. The rules are: the maximum number of electrons in a shell is given by the formula 2n square, where n is the orbit number or energy level index. So, the maximum number of electrons in different orbits are: first orbit or k shell, which is equal to 2 into 1 square, which is equal to 2. Second orbit or L shell, which is equal to 2 into 1 square, which is equal to 8. Third orbit or M shell, which is equal to 2 into 1 square, which is equal to 18. Fourth orbit or N shell, which is equal to 2 into 1 square, which is equal to 32. The maximum number of electrons that can be accommodated in the outermost orbit is 8. Electrons are not accommodated in a given shell unless the inner shells are filled. That is, the shells are filled in a stepwise manner.